Hello, my name is Darryl Shirley, and this is my tech demo number one for Math 25051 Multivariable Calculus. In this tech demo, we were tasked with plotting a line, a plane, and a cylinder. We were also tasked with graphing the ellipse created from the intersection between the plane and the cylinder. The program I used to graph this is the Desmos 3D graphing calculator, as you can see on the screen. For the line, we were given a direction line of 1, 1, 1 times t and a starting point of 10, 0, 0. To show that in Desmos, I combined the direction line and the starting point into one parametric line of t plus 10, comma t, comma t, as you can see as the top choice, and I made it go from negative 20 to 10. And so as I click on this circle to the left, it'll bring up that line in 3 dimensions. So I rotate around, you can see how it intersects the x-axis, y-axis plane, and that's that line. And so after that, I also created the plane. And the plane was more straightforward. All I had to do was put in 2x plus y minus 2z equals 2. And for that one, as I click the circle, this is the plane in green. And you can see as it has its own direction and everything. And then next one was the cylinder. And so I plotted that as x squared plus y squared equals 3. And then I also had to do click this little button where it says extended 3D, because otherwise it would just be in the two-dimensional plane where it's just a circle. So when I extend 3D, it becomes a cylinder in 3 dimensions, and it goes on infinitely, since z can be all real numbers. And for the intersection of those two, I'll show it both lines on the same, or both objects in the same time. We go vertically, click this button, and you can see here, as I zoom in, that there is a little section inside where you have a ellipse created from the intersection of the cylinder and the plane created by that equation. And to calculate that, I first calculated the parametric equation for the cylinder and got 3 cosine, or square root of 3 cosine and square root of 3 sine t. And then I had that going for 0 to 2 pi, so that would get a full circle. And then I plugged in, or I solved for z for the plane and got 2x plus y minus 2 over 2 equals z. And then I plugged that into the parametric equation for the cylinder, and I replaced the x and y components with that from the cylinder. And so we have the x was square root of 3 cosine t, and y was square root of 3 sine t. And so then you get the 2 times square root of 3 cosine t plus 3 square root of 3 sine t minus 2 over 2. And then without those on the screen, and just this one equation going from 0 to 2 pi, this is the intersection created from them. And you can have all of them at the same time, and as you can see, it's right on top of the plane. And then if we just have it just the cylinder, you can see it's right along the cylinder at that angle. And at the same time, it's kind of hard to see, but you can kind of see like the little extra line there. You can see it right there, but it's still blue. So if I get rid of the cylinder, there it is. Get rid of the plane, there it is. So that's right. That's how you can see that it's exactly where it's supposed to be, and how this calculation works for this. And so yes, that is my tech demo, and thank you for watching.